Hey, here we go. Just like I said a couple days ago that we were going to do compound inequalities, and what compound means is we're going to have two lines on one graph. We're going to solve two inequalities to get it onto one graph. Compound means more than one. So, again, if you know how to do order of operation and isolating or reverse order of operation to isolate that variable, you're going to be A-OK. Compound inequalities is just like I said. It's two inequalities it could be more, but in ninth grade we're just going to do two for the most part, joined together with, and now this is the important part, we have usually an and statement or an or statement. Okay, so we're going to pick or first. Okay, and so that means in our answer we have to have the or in our question. And usually the or graphs, when we have an inequality that's an or, the graphs go in opposite directions. Alright, so also when we write our final answer, we want to make sure that the smallest number is over here on the left of the or, and the larger number is over here on the right. Negative 2 is smaller than 3. And so if you put it in what we call standard form, and all that means is the smaller one's over here on the left and the larger number over here on the right once we get our x's by themselves, then always signs will go in opposite directions. The signs will always point in opposite directions. Now it could be less than or equal to, but they'll always point in the opposite direction. Okay? So if we go over here and graph this guy, which they did all the work, and they said, hey, just go over and graph this guy. So we're going to have a closed circle on 2, and that says x is all numbers less than 2. So that means it goes this way. And this guy says x is all numbers greater than 3, but I don't have an or equal to sign, so just like we've been practicing for the last couple of days, it goes that way. So we have two lines on the same graph. So most of the time now we have two math problems to solve. When they have an or statement, it's already broken up like this into two math problems, and so what we have to do is just solve the two math problems. It doesn't matter which one you pick first. We may as well do the one on the left. And I got x, bring down your sign, negative 7 plus 4 is a negative 3. We're going to go over here and solve this guy. It's only one step. And I got x is greater than or equal to 6. Now, as I look at my final answer here, here's my first problem, here's my second one. Negative 3 is smaller than 6, and so that I can just put the or in there and put a box around my answer. I must have that word in there though. You just can't leave them hanging like this, because this is what we call compound inequality. There's two answers here. Well, there's lots of answers, but there's two boundary lines we call them. We call one first boundary line is the negative 3, which is right there. It's an open circle, so it doesn't include negative 3, but it includes everything smaller than negative 3, like negative 3.1 would be a part that I could plug into that and it'd still be true. Then over here when I go to 6, looks like I have a solid line and I want everything greater than 6. So, a couple things. Standard form means the smaller one goes on the left, larger one's on the right. It just happened to be that way when I did my math and I set the problem up. I must have that or statement in my answer, if it's an or statement, and then I look over here, my line should be going the wrong or opposite ways. I also look over here, my signs are pointing to the left over here and pointing to the right over here. Okay, so those are some things to kind of keep an eye on for. Sometimes if I had an x is greater than over here than negative 3, well then that means my line's going this way and I know something's wrong, because or statements right now for most of the time in ninth grade go in opposite directions. Later on we'll talk about it if we get to that by the end of the year of when they overlap and things like that are crazy. All right, here we go again. It's only one step, but we got to remember that rule on inequalities, that if I divide by a negative, you have to flip the sign. Okay, and negative divided by negative is a positive 3. Let's get that 5 to the other side. Now, this is a classic example. Before I write my answer, which I have to rewrite it because 3 is bigger than 1. So this math problem has to go first over here. I've got to write it in standard form. I'm going to write the word or, and then I'm going to move this guy over there. X is greater than or equal to 3. So keep the signs just like they are. Now, I have the smaller one first, the larger one second, and they're pointing in opposite directions. Okay, this is very important that you just don't put the word or up here, because then when I go over here to graphing, it makes a lot more sense because I have an open circle on, oops, positive 1, not negative 1. So let me get that fixed. Positive 1, and my line's going to go to the left, and then I have a closed circle on 3, and my line is going to go to the right. Okay. All right. So, not too terribly bad. All of those are just one-step equations. So that's not too bad. Now we got it a little bit more challenging. So, here's my first math problem. Just dig right in. Don't even bother rewriting it. Less minus 9 from both sides. Now, 17 take away 9 is 8. Let's get rid of that 2. Let's go solve this guy. Interesting. 10 minus 10 is 0. We can have a 0 there. We still are going to divide by 5 here. And 0 divided by 5 is still 0. Alright. So 0 is smaller than 4. So I'm going to start writing my answer over here. X is less than 0. There's my word or. X is greater than 4. 0 smaller than 4, so he's got to go first. And now that makes my graphing also easier to graph. So I got an open circle on 4, goes to the left. X is greater than 4, open circle on 4, goes to the right. Now sometimes I'll come over here and make sure I didn't forget like the or equal to sign. Nope, neither one of them has them, so they're both open circles. That's the easy thing to kind of lose on the way down, is you bring in your signs down, but you forget to bring down the or equal to sign. All right, let's get rid of that 14. Get rid of that 7. Let's go solve the other one. Now, again, I'm comparing. Negative 2 is smaller than 2, so I'm going to go over here to write my answer. So it's nice and easy and right above my graph. I'm going to write or X is greater than or equal to 2. Negative 2 is smaller than 2. Let's go fill in our graph. Closed circle on 2, negative 2, and open circle on 2. Going this way. Box your answer. Alright? You give number 5 a shot. Now don't forget, just like we were doing the other day, you got to do parentheses first. So this one's going to take a couple of steps over here, but do your work. And make sure you put your answer over here in standard form. Alright, pause your video, and when you're all done, let's see how you did. Okay, let's see how you did here. Did you know that negative 4 was smaller than 2? Probably. Okay, so I got negative 4 on the left side, and I got 2 on the right side, because 2 is more than negative 4. And there you go, my signs are going the opposite way. Uh-oh, I noticed something right here. I see that on this guy I forgot to bring down that or equal to sign. So I want to go over here and fix them. Alright, so, yep, that's always a good thing, like I was saying earlier in the video here, is to make sure that, you're looking over here, the or equal to sign, or just the greater and less than sign, open circle. There you go, made a boo-boo right there. Alright, caught it though. Alright, keep an eye on those things. Now, here's the second type, called an and statement. I like these guys, because these guys go towards each other. And so now if I was to graph this guy says x is greater than -6, so greater than means more than, so I'd have an open circle on greater than, my line starts going this way. And it says x is less than or equal to 1, so that means a closed circle on 1. If I want all the numbers less than, that means it goes this way. Okay? Don't worry about that interval notation again. I'm not sure how that guy keeps getting in there. Alright, because the solution to an and inequality fall between these two guys, so what we want to do is when we have this equation like this, let's just copy this guy, and we say and x is less than or equal to 1. Now this is very important. If you have the -6 is smallest, and the 1 is the largest, and I know it's an and statement, automatically I put an x in the middle. I put the smallest of the two numbers on the left, because it wants to be in standard form, and I put the largest guy on the right. Now, when I do my inequality signs, this guy really says x is greater than -6, and you see how the fat side's next to the x? I'm going to make that fat side still stay to the x. Now it looks like I'm flipping the sign, but I'm not really flipping it. I mean, it appears like I'm flipping it, but that really says you start in the middle and you say x is greater than -6, and, so you go back to the x is less than 1. So signs on and statements, I'll put that in parentheses, will always point to the left. See how they're pointing to the left? Okay. But again, the way you read this is x is all numbers greater than -6, so you start in the middle and read this way, and then you come back to the middle and say x is all numbers less than or equal to 1. So that means all these numbers in between. Any one of these numbers I could plug into this equation over here, or inequality, and it would make a true statement. Alright, this one takes a little bit, but what I like about these guys, especially when they write it like this, and it's in the middle already. So if I covered this guy up, and I want to grab my white marker here, let's make it nice and big. Oh, good, it is. If I said solve that equation right there, you would probably tell me, hey, let's subtract 4 from both sides. So let's subtract 4. Math happened. I got the x in the middle, and you're going to bring your sign down, and 2 minus 4 is a -2. Okay? Now, you just solved that one. Now, if I said, okay, let's pretend this guy wasn't over here, and I said solve that, wouldn't you still minus 4? Okay? So, we'd minus 4 on this side, and we'd minus 4 on this side, and 9 take away 4 is 5, and we're going to bring our sign down. So what we're going to do is we're going to solve two problems at the same time. We're going to try to keep that x in the middle, and we're going to get rid of whatever else is outside of that x. Okay? So we're going to solve two problems at the same time. That's kind of why I like these guys. Now, very important, sometimes they'll have it set up correctly like this one. My -2 is smaller than 5, and so it's already in order. Whoops, we don't want to do that. It's already in order, and so what we can do is just draw our box around it. Now remember that last step that I said the arrows point to the left? Both arrows are still pointing to the left. So if for some reason I'm working through my math problem and I hit a negative and I flipped a sign and I had one sign going this way, x in the middle, and the sign going this way, it's like, wait a minute. This is an and statement. Fisher told me that, hey, the sign should always be pointing to the left, so something's wrong. Then you can just go back and check your work, okay? All right, so we can just leave that answer there. Let's go graph this guy. Solid circle on -2 goes to the left. Whoops, bad me. Because that says x is greater than -2. Okay, you read from the middle this way. Okay, so now this is that condition where it's not pointing the way it is, because you read from the middle, x is greater than -2, and x is less than 5. So I have an open circle on 5, and it goes towards each other. All right? So that's kind of a little bit of a hazard there. You start in the middle and say x is greater than -2. All right. Another one, I love it, because I can solve two problems at the same time. So what I'm going to do now is, I know I need to get rid of that -13 by adding 13. So I'm going to put plus 13 over here, and I'm going to put plus 13 over here. I like to put the plus signs there, so that there's my math problem. 8 plus 13. Okay? And I know 8 plus 13 is 21. I'm going to bring that sign down. The 13's in the middle go away, so I just have still a 7x in the middle. I want to bring that sign down, and now I got -27. Let's get my calculator. My brain's not thinking very nicely here today. Plus 13. Oh, I should know that. That's a -14. Let's get rid of that 7. Right now it says 7 times x. We're going to divide by 7, but I want to do two problems at the same time. -2 is smaller than 3, so they set the problem up right. That I can just put a box around my answer and go over here and graph it. Now again, that says x is greater than -2. You read from the middle to the left on that first half there. So that's an open circle on 2, and it goes this way. Open circle on 3 goes that way. And I want to go back and make sure I didn't forget any or equal to signs. Nope, I was good all the way through. Alright, so they both should be open circles. Alright, so I think you're going to like the and statements, kind of like I do. Try number 8, pause your video, and then let's see how you did. Okay, let's go see how you did here. Got rid of that 4 first. Solved two problems at the same time. 3x, -12. Last step, divide by 3. -4 is smaller than 2, so I like it. Should have closed circle on -4, closed circle on 2, and everything's good. Alright, let's go do a fraction one. This one's kind of a little bit tight on showing your work. First of all, we got to get rid of that +1, because there's my x. So let's -1 from both sides, and then we'll worry about how do I get rid of that fraction there. -1 and -1, so -2. I still have my 2/3 x in the middle, and I have, let's see, 4 over here. Now, this is where now we've done enough math that we can kind of squeeze this in here. Instead of dividing by 2/3, we've been talking about this all year long. Let's take the reciprocal and multiply by 3/2, because that way I don't have to use my calculator, because I'll show you here in a second. Now it's kind of hard to show in the middle there that you're multiplying by 3/2, because there's really not enough room. But if we see the 3/2 here and the 3/2 here, we can just do this, say it goes away, and just put our x in the middle. Okay? Because we know we're doing it over here. We've done it enough times. Now, here's how I do my fractions. I'm not going to pick up that calculator and say 3/2 times -2. I'm just going to say 3 times -2, which I know is a -6, and -6 divided by 2 is -3. I don't need to pick up that calculator and waste some valuable time. 4 times 3 is 12, and 12 divided by 2 is 6. I just did that without even picking up my calculator. Alright, -3 is smaller than 6, so it's in standard form already. They'll probably give them to us in standard form of putting the smallest number over here and the math problem, a larger one over here. But So always just kind of check that guy out, okay? Open circle on -3, and it says x is greater than -3. And I want a closed circle on 6, and my line goes like that, towards each other. So this guy really is going this way. We just don't put the arrow, and this guy's really going this way. And they both collide in the middle there. So any number that's underneath that, including decimals, I could put into this equation. Sometimes I'll put 0 in, because 0 is a nice, easy one. If I put 0 in there, 0 times -2 is 0. So then I look, is 1 greater than -1? Sure is. Is 1 less than 5? Sure is. So now I know my signs are going this way. 0 is a good number to use to check, because we can do 0 mentally. Okay, and 0 right now is part of our solution. All right, last one, I believe. Try number 10. I want to hand out the papers to my kids at school, and let's see how you did. Come on back. All right, let's see how you did on the last one here. Got to get rid of those parentheses. Get rid of that 12. Get rid of that 2. 5 is smaller than 8. We're good. All right. So today, jump in on these guys. Let's see, I think we have about 10 problems there as well. Yep, 10 problems. And we hope to see you in school tomorrow. Have a good day.